Okay, welcome to part 2 of Roots and Radicals. In this video, we're going to look at the cube root of a number. The cube root of a real number, a, is written in this form. I'm going to come up here. The cube root of a. This is the index right here. And notice, because we've written a 3 there, then we're talking about the cube root, not the square root. Okay, the cube root of a equals b means that a raised to the third power, b raised to the third power, I wrote that backwards, is equal to a. So b raised to the third power is equal to a. Let me get on here and click to the next slide. Okay, if I want to simplify the cube root of a cubed, here's what I've got. The cube root of a cubed. The question here is, what do I raise to the third power to get a cubed? Just like we had up here, b raised to the third power gives me a. So what I'm looking for here is, what do I raise to the third power to get a cubed? Well, that would obviously be a. So the cube root of a cubed is equal to a. All right, let's look at some examples so that we can kind of get this understood. Scooting down, I hope I'm not making you dizzy by doing that, sorry. Okay, simplifying radical expressions. Okay, for an example, I have here the cube root of negative 125. So the cube root of negative 125. So what this is asking me is, how many groups, what do I have under here that has some groups of 3? So we're going to begin by expressing the radicand as an expression that is cubed. So here's how I'm going to write it. In the notes, it put it into exponent notation. I'm going to take this just a little bit further. I'm looking at this as negative 5 times negative 5 times negative 5. Then I could write it, if I wanted to, as the cube root of negative 5 cubed. So what this is saying is that every group of 3 now, instead of just every group of 2, every group of 3, and this is a short way to write a group of 3 negative 5s. Oh, I'm sorry, I've scooted over not far enough. Every group of 3, okay, every group of 3 gets to come out of the radical as 1. Okay? So the cube root of negative 125, because it's one group of 3 negative 5s, gets to come out as a negative 5. Okay, we can check our answer if we wanted to by doing negative 5 raised to the third power, and that would give me negative 125. All right, now let's look at a few examples. Okay, here are some examples. I'm just going to scoot this over so you can see what we're doing. Okay, letter A. The cube root of a cubed, b cubed. Well, the first thing that I'm going to do is write this in terms of its factors. So I'm going to do a 3 times and b 3 times. And now I'm looking for groups of 3. So 3 a's right here, 3 b's right here. The 3 a's get to come out as 1. The 3 b's get to come out as 1. And remember, we're always multiplying between those two. So the cube root of a cubed b cubed is just a times b. Now let's look at letter B. The cube root of x to the 4th, y to the 5th. Okay, I'm going to do my factoring here. That's 4 x's and 5 y's. 4 x's and 5 y's. We're looking for, oh, I left off my 3. This is a common mistake. Please don't do that. Left off my 3 there. I'm looking for groups of 3. So I'm going to do 3 x's. Here's 3 y's. This group gets to come out as 1 x. This group gets to come out as 1 y. And remember, they're multiplied together. And then don't forget to bring this down. The cube root of x times y squared. Because y times y is y squared. So this is the simplified version of the cube root of x to the 4th, y to the 5th. Okay, now I want to try letter C. I'm going to do that one for you, and then I'm going to let you try letter D on your own, and then we'll go through it together in class. So we have the cube root of 27a to the 4th. Okay, the first thing I'm going to do is take my 27, okay, here's the cube root of 27a to the 4th, and the first thing I'm going to do is take my 27 and factor it. I know 27 is 3 times 9. I know 3 is prime, so I'm going to circle it. 9 is not prime, so I'm going to keep factoring it. So 3 times 3 is what 9 is. 3's are prime, so I've circled them. When I have all of my numbers prime, then I can come up here and put it into my radical. So 27 is 3 times 3 times 3. A to the 4th is a multiplied by itself 4 times. Now I'm looking for groups of 3. So here's 3 3's. Here's 3 a's. So 3 3's get to come out as 1 3. 3 a's get to come out as 1 a. And don't forget to bring this 3 down. The cube root of this little guy is left inside all by himself. So 3a times the cube root of a. I'd like for you to try letter D now. Pause the video and try letter D, and then we'll come back and work it together in class. Okay, let's look at this. Find the indicated root or state that the expression is not a real number. Okay, letter A. I'm going to move this up just a little bit. Letter A, the 5th root of -1. The question is there a number that I can multiply by itself in this case 5 times to get -1? That's the question here. Well, let's check and see. I'm thinking that -1, if I multiply 1 times 1 times 1 times 1, it's going to be 1. So let's do -1 times -1 times -1 times -1 times -1. That's 1, 2, 3, 4, 5 -1. So I've multiplied -1 by itself 5 times. Let's see what I get. Well, a -1 times a -1 is 1. -1 times -1 is 1. And then I have a -1 left over. So 1 times 1 is 1. And I have this -1 left over. And 1 times -1 is is -1. So -1 times -1 gives me 1. -1 times -1 gives me 1. And I'm bringing down this -1. 1 times 1 is 1. Bringing down my -1. 1 times -1 is -1. So yes, there is a number that when I multiply it by itself 5 times, I can get -1. And that answer is -1. Okay? An odd root of a negative real number is always negative. Now this next one is asking me the same question, but it's saying, is there a number that I can multiply by itself 8 times and get negative 1? And the answer here is no, because the 8, that index, is even. And if I multiply 8 6, 7, 8, this is going to give me 1, 1, 1, and 1. Anytime I multiply an even number of negatives, I'm always going to get a positive answer. So there's no way I can get a negative when I have an even index. So this is very important. An odd root of a negative number is always negative. An even root of a negative number is always non-real. So this is not a real number. Okay, that's a very, very important piece of information there. Okay, we're going to stop this video now. We'll work one more problem in class together. So please get these notes down and be ready to ask questions.